This is lesson 8.4. So we're going to start with a combined theorem. This is actually two different theorems, but they mean the same thing. The triangle proportionality theorem and the three parallel lines theorem. So if you have parallel lines that intersect two transversals, it's going to divide the transversals proportionally. So that means they're not equal length. It didn't divide them equally, but this part compared to this part, like QT compared to SU, would be the same as TR compared to UR. And the same thing here, these little pieces. So what's really nice about this is we can make our fractions exactly as it appears. So if my picture looked like this and I had x, y, a, and b, I could say x over y equals a over b, exactly as it appears. If my triangle had been turned the other way, and we had x, y, a, and b, I could do x over a and y over b, and it would be fine. It's still exactly how it appears in the picture, so it does not matter what you do there. You could just make it look exactly how the picture looks, and you should be good to go. All right, so that works if it looks like a triangle or if it's multiple parallel lines like this and they don't connect ever. The converse of the triangle proportionality theorem just says that if I see that the two transversals have been cut proportionally, that means those lines were parallel. So for example 1, we want to find QR, so let's put a variable there. I'm going to do this as it appears. I'm going to put the x over the 9 and the 4 over the 6, because that's what they were like. 4 was over the 6, x was over the 9. So when I cross multiply, we get 6x is 36, so x is 6, so QR is 6. And that's all there is to that. So you can go ahead and try this one. Pause. Answers are posted online. For example 2, they're giving me some measurements, and they want to determine if BD is parallel to AE and explain why or why not. So let's draw out this picture. CBDAE. So BA is 33. BC is 27. CD is 44, and DE is 25. So I'm going to compare. I'm going to put 27 over 33, and I'm going to put 44 over 25, and I'm going to check to see if they are equal. I could either reduce both fractions and compare their decimals, or I can cross multiply. So 27 times 25 is 675, and 33 times 44 is 1452. Very different numbers. They are not equal. So this is no, the transversals are not proportional. If you just say no, I'm okay with that. As long as you've shown the work, no will be fine. So you can go ahead and try this one. Pause. When you want to check your answers, they're posted online. Example 3, Megan is drawing a hallway in 1-point perspective for any of you taking art. She used the guideline shown to draw 2 windows on the left wall. They're giving me all those segments are parallel and then the measures of some of them. We want to find WX. So what this really is, we have 4 parallel lines. We have A, we have B, we have W, we have X, we have Y, we have Z, we have C, we have D. And as for measurements, A to B is 8, D to C is 9, Z to Y is 5, and we don't know W to X. It doesn't matter that there was a segment between them. They're still part of parallel lines intersecting these transversals. So I could still set up 8 over 9 equals X over 5. So it's going to be 9X equals 40. And we get X is 4.4 repeating. So I'm going to say WX equals 4.4 repeating centimeters. All right, example 4 is another together. So we want to find FH. We want to find this whole side. If I made just this bottom piece x, together x and 120 will be the length of FH. So if I made this x, I have 120 over x and 150 over 300. And by the way, I know I'm allowed to set up these proportions, even though they didn't tell me the lines are parallel, because angle 1, angle 2, and angle 3 are corresponding angles that are congruent, which makes the lines parallel by the corresponding angle converse. So when we cross multiply here, I'm going to get 150x equals 36,000. When I divide by 150, I get x is 240. So 240 and 120, FH is really 360 yards. So here's one for you to try. Pause if you'd like. Answers are posted online. The other kind of problem we're going to talk about today, same idea. We're going to be breaking up something proportionally. In this case, if an angle bisector is in the triangle, it will break up the side it intersects proportionally to the other sides. So again, if we put some numbers, letters on here, let's say A, B, C, and D, I could put A over B and C over D. I could also take the side, the little chunk, and put it with the whole side that it's touching. So C over A, D over B, or B over D, A over C. Again, as long as I'm not going diagonally to make my proportion, I'm probably okay. So for this one, I'm going to do 7 over 13, because look at that, it even has the bar there for me. 7 over 13 equals something over x. So I'm not going to put the 15 there because 15 is the whole segment and I want just a little chunk. Let's pretend just for a second that this was like 2. If this was 2, I would know that was 13 because 15 minus 2 is 13. Just because we don't know what this is and we're calling it x doesn't mean I can't still do 15 minus that and put 15 minus x there. It just means I have more than one term and I have more than one x in the problem. But I'm still going to be able to do everything I need to do. So I'm going to do 13 times all of 15 minus x equals 7 times x. So that's going to be 195 minus 13x equals 7x. 195 equals 20x. And when I divide by 20, x is 9.75. So this is the last problem. Try it if you'd like. The answers are posted online. But that is the end of section 8.4.